Now we shall discuss about streamlines, path lines and streak lines, which are the geometrical representation of lines, which also helps in developing the mathematical description of fluid flow, and that is also very important. So first we shall talk about streamlines. In any flow region, if we draw these imaginary lines, these 4 lines are drawn in any imaginary fluid region or actual region. Suppose we are sitting in this room where fluid is flowing, this air is moving, it may be due to the fans are rotating or because of air conditioning blower, this air is moving. And if we can draw these imaginary 4 lines in such a manner so that if we draw tangent at any point, then this tangent represents the velocity at that point, then these lines are called streamlines. So these lines are streamlines if at any point the tangent represents the velocity at that point, then these lines in that fluid region is called streamline, right. So if these are streamlines, in that case v is the velocity here, this v. Now for 3-dimensional flow, this v will have 3 components in x, y, z direction, which may be written as ui plus vj plus wk. Now by the definition of the streamlines, what will happen to v cross? This is a cross vector product, v cross ds. What is ds? ds is the small line segment. When ds tends to 0, it will become a point, but if we take a very infinitely small distance line segment, then ds will have also 3 components in Cartesian coordinate system in x, y, z direction. So ds may be written as I dx plus j dy plus w dz. So v cross ds is equal to 0, because v cross ds, it means that there is no flow in this direction perpendicular, because this v will have 90 degree. If it is 90 degree, it means that it has, this v has no component in direction perpendicular to this line at that line segment. So v cross ds will be equal to 0. If v cross ds will be equal to 0, then this may be written in the form of equation. V may be written as iu plus jv plus kw, s may be written as I dx plus j dy plus k dz, and when v cross ds is equal to 0, this equation may be written as dx over u is equal to dy over v is equal to dz over w. Now similarly we may have steam tube concept. So in any fluid region, if we can define these number of stream lines on the periphery of this surface, then by definition of the stream line, we know that fluid cannot cross these lines. So it means that if we can convert any region with the help of these so many types of steam tubes, which may be circular one, which may not be circular one, may be having any kind of shape, but fluid can cross this area, but fluid cannot cross these boundaries. So it means these lines will act as a surface. On this surface we have number of steam lines. So this full figure is known as a steam tube. By concept of the steam tube, though we are not having solid boundary as such in that fluid region, but by defining these steam tubes, we can consider this fluid is flowing through a duct or a pipe, and we can analyze that fluid flow.